week on multiplying decimals. We're going to start with some estimations. We're going to do some patterns of products, multiplying by powers of tens. We're going to do decimals by whole numbers, and then decimals by decimals. We're going to do all of these. Actually, I'll grab it. Okay, our first exercise for the review today, we're going to round each decimal to the nearest 10 and then to the nearest 10. So you're going to have two answers for each of these sticks. So you need to have a total of 12 answers to these 6 problems. One to the nearest 10, one to the nearest 10th. Go. Okay, this one should have been relatively easy. The key is focusing in. When I am rounding, I always go to the next place over to figure out what I'm rounding to. So the first one, round to the nearest 10, means I look at the ones place. So 9 means that becomes a 20. To go to the nearest 10th, that means I go to the hundredths place. The 4 means that it stays the same. So 19 and 5/10.
What's the first one then?
20.
No. The first, the decimal, and then the number right there. Wait, what's that?
The tenths?
No. The decimal, and then it's the 5. What do you call that one?
The tenths.
Oh.
So I'm rounding to the nearest 10th, meaning I need to look at the hundredths place to figure out where the 10th place rounds to. Okay, number 2, again, looking at the ones place means that rounds to 10. Looking at the tenths place means I go to the hundredths. Sophia? Guys, if you have a question, raise your hand. All this chatter is not good. Billy? So going at the 6, that means it goes up. So the 9 becomes a 0, meaning that the 1 becomes a 2. So rounding, that actually becomes a 12. And because I'm rounding, I would include the tenths place. So even though it's a 0, because I rounded, just to show that that was a rounding thing, we include that decimal. Next number, again, I start at the ones. The 4 means that the 10 stays where it is, 120. The 5 means that the tenths is going to go up 1. So 124 and 4/10. Try that again. There we go. I didn't like the way that 0 looked like a 6. Number 4. The ones is a 5, meaning that it's going to go up. So that's 250. The hundredths is a 3. Meaning that's going to become 245 and stays at 3/10. 10, the ones is a 0, meaning it just stays at 10. The hundredths is an 8, meaning it's going to go to 10 and 9/10. The ones is an 8, meaning it's going to become 1,260. The hundredths is a 4, meaning it's going to stay at 1,258 and 4/10. Are we good on those? Yeah. Are you okay? She's looking really out of it today. If you need to go see the nurse, we can send you down. Okay. Okay, next one. We've used these area models when we were doing fractions to talk about multiplying and dividing fractions. Now we're going to use them for decimals because it's really the same concept. So where we used it to show, and here's the key, guys, we're talking product. Product means what? Multiplication. So 2 fractions. An area model, just move, can also represent the product of 2 decimals. So write the multiplication problem represented by the area model. So what multiplication problem does this show? I'm going to give you guys about a minute and a half, talk with your table, see if you guys can figure out what multiplication problem is being represented. I'll give you a hint, it's a decimal problem. Okay, who thinks they understand what decimals were represented on the first one? Jaden, I saw your hand first. 7/10 times what? Times 5/10. Now, big key, what did it equal? 35 hundredths. So, for those of you who may not have been able to figure it out, all he did is he said, okay, if I count across, there's 1, 2, 3, 4, 5, 6, 7 tenths is where I drew this line. Going up, 1, 2, 3, 4, 5 tenths is where I drew that line. And then if I count, I now have this box that's double shaded. Remember that we said that's where the answer is. That's the overlap. And if I counted, there's now 35 double shaded blocks out of 100, or 35 hundredths. Does everybody see that one now? Okay. So now we're going to do it the opposite. They've given us the blank in the problem. Now I want you guys to model it. So this is where using two colors is helpful if you've got two different highlighters or two different colored pencils. You can do shadings, but shadings is going to be a little more difficult for you to figure out the double part. Okay? So I'll give you guys about 2 minutes to do the number 2 as well. So the first one, it doesn't really matter what colors you use. Just make sure you're using two different ones. So 2 tenths means that I'm going to shade one of them in 2. Doesn't really matter if I go up, down, or from the bottom, but one's going to have to go in each direction. My second one, I'm going to go 8 tenths. So that's going to come up here. So I'm going up to the 8 tenths. Had a couple kids asking last class that got a little confused on this. Remember, 8 tenths is the same as 80 hundredths, right? So if I'm going to do 8 tenths, I need to color all the way across. And then 2 tenths is going the other direction so that we can figure out where the overlap is. Now you should be able to clearly see my overlap is this part right here. So that's what my answer is. So how much overlap was there between the two? Jaden? 16 what? 16 hundredths. So 2 eighths times 2 tenths times 8 tenths gave us an answer of 16 hundredths. So that is the one you should have been able to develop based on that. Now, I actually really like this next one. Benny says the product of any 2 decimals that are less than 1 will always be less than 1. Angel says the product can be, hence, is can be as definitive as always. No, can be means sometimes it will, sometimes it won't, right? So it means greater than 1. Who's correct? So if you guys talk as a table, who is right? Is it Benny or is it Angel? They give you a really good hint. Use the area model to explain your reasoning. So I need an explanation of your reasoning as to who is correct and why. I'll give you guys about 3 minutes to work through this. Talk about it. Okay, guys, how many of you thought that Benny was right? Raise your hand. Okay. Quick test-taking strategy. Anytime you see a definitive, it says always, you've got to be really confident to choose that. How many of you think that Angel was right? Only 4 of you? 3? 4? 5? Now we're up to 5. Guys, 90% of the time, if you see one that says always and the other one that says can be, 90% of the time that can be is going to be the correct answer. Why? Because can be gives you a lot of flexibility. Always is very hard and firm. So you have to be very confident to choose a always over a can be. In this case, Benny was right. So who can explain the reasoning why? Austin.
Benny is correct because multiplying fractions by another
Guys. Callie.
Well, Eddie is right because fractions are the same as decimals, but
Okay.
in a different form. And multiplying a fraction by another fraction less than 1, both less than 1, means that you're finding part of that one fraction, making it smaller.
Good. And that's why the area model was such a good hint. If I'm taking part of a part, is there any way it's going to be bigger than 1? No. Okay? So the bottom line on this one, Benny is correct. Whoa, hello. Benny is correct. Part of a part will never be greater than 1. Okay, everybody good on this one? Everybody understands why Benny was right. More importantly, I hope you guys picked up my test taking strategy. Be very cautious of those words always and never. Most of the time, if you see an always, that's going to be a wrong answer. If you're taking a complete guess, go against always. Okay,
Don't take your complete guess.
page 137. Yes. Yeah, that wasn't allowed.
That's not.
No, you can't choose both of them. Our next activity. Guys, please pay attention. Raina. Kenji needs to calculate the area of the floor in the hallway. I don't know what's going on with the pen today. So you can buy new carpeting. The floor is 32 and 7,500 feet long and 7.5 feet wide. Kenji said, I use estimation to help place the decimal point correctly in the product. So if I have an idea on what it's going to be, it's going to tell me how many digits I should have in my answer. So he said the area of the floor is 32 and 7,500 feet times 7 and 5/10 feet. He estimates the product. He says 32 and 7,500 is close to 30. Do you guys all agree?
No.
Why not?
Well, it depends on what he's rounding to.
He's just trying to make the math easy. He's just getting basically the number of decimal places.
Okay.
So you're good with it? And he says 7.5 is close to 7. You guys good on that one? What do you think, Billy? What do you think, Billy? You go with that? So you don't understand rounding rules at all? Oh, thanks for finally rejoining us. You need to be careful, Billy. This new seating arrangement has been the worst for you than just about anybody. Oh, let me hit pause. Okay, so now that Billy understands what we're doing, I agree with him. I would round that to 8. So for Kenji's estimate, he said it's going to be 210. I say 30 times 8 is going to be closer to 240 for his answer. You're leaving. Yes, you're being checked out for an appointment. Okay, highlighters. Quick note. Multiply decimals as you would whole numbers. Then place the decimal point in the product. So I'm going to develop a rule for you guys, an algorithm, to help you do this. I don't think there's probably more room up here, so let's go under the habits of the mind. So multiplying decimals. Go ahead and write this into your math books. There are 3 steps to multiplying decimals. Step 1, count the total number of decimal places being multiplied write it to the right and circle it. Okay, so for our example, we'll use the one that they've given us. I'm multiplying 32 and 75 hundredths times 7 and 5 tenths. I count. How many total decimal places do I have? There's only one person in this room that sees how many decimal places we have? Seriously? Okay, Austin, how many total decimal places are there? 3. There's 2 in the first number, 75 hundredths, 1 in the second number, 5 tenths. So I take a 3 and I write it right here and I circle it. Okay? That's step 1. Step 2, multiply like the decimals aren't there. Which brings up the next point. Do I have to line up my decimal places to multiply? No, I do not. Lining your decimal places is your rule for adding and subtracting. The rule for multiplying is different. Multiplying, I set it up just like if I was multiplying two numbers. Okay? The problem with lining up your decimal places, you're then going to add trailing zeros. You're going to add more decimal places, make your multiplication more difficult, and increase your chances of an error. Are you able to do that? Yes, as long as you still account for them. But it's much easier. Just write down the two numbers, count the decimal places. So in other words, step 2 is saying, now I'm just multiplying 3,275 times 75. I'm pretending the decimals aren't there. Step 3, place the decimals in the answer from the right. Okay, so I'll give you guys all a chance to make sure you've got all that written down. So going back to our example, what does that look like? I've now multiplied those two. There we go. I've now multiplied those two numbers. I come down to my answer. I start at the right, and I say, okay, I have 3 decimal places. So I come in 1, 2, 3. That's where I put my decimal. Make sense? Okay, now we learned a really neat thing in first period. If you guys look at your book, do you have those two numbers? Look at the example in your book. They gave you a different answer. So now that none of you wrote that down, because I'm confident that none of you did, I want you to actually multiply the two correct numbers, see what you get. So multiply 32 and 75 hundredths, 7 and 5 tenths. Find the answer. I don't care where. Anywhere on your paper there. Okay, guys, who got the right answer?
Me.
There's the work to let you see it. Should have gotten 245 and 625 hundredths.
Okay.
Everybody get it right? Okay, next one. This should be an easy one. Use Kenji's estimation strategy. Insert a decimal point into each sentence to make it true. So here's our whole key. Insert the decimal point. They've already done the math for you. So use estimation, figure out where the decimal should go, and put it in. That should take you all of about a minute. Go. So Kenji's strategy was actually really simple. He just said, okay, that's about 53. 53 times 1. That's going to give me 53. So how many decimal places should I have? How many numbers? Actually, it's easier to say how many whole numbers should I have? 2. So I put 2 in. 43 and 65, 658 thousandths. Next one, that's about 8. 6 tenths is about 1. Should be 8. So I should have 1 number before the decimal. 4 and 75 hundredths. 94 hundredths is about 1. 24 is about 5. So it should be somewhere around 25, meaning it should go between the 3 and the 4. If you guys look at the rule that I gave you, that rule also works here, doesn't it? How many decimal places do I have between 52 and 6/10 and 83 hundredths? Sergio? 3. I have 1 there, 2 there. That means I need 3 decimal places. I put 3 decimal places in. Right there's where it would go. Here I have 1 decimal place, 1 decimal place. So how many should I have in my answer? 2. 1, 2. There we go. Here I have 2 decimal places, 1 there. So how many should I have in my answer? 3. Does that make sense? Seeing how all this comes together now? Okay, this page. Let's skip that one. Actually, I'm going to do this one because literally all you're going to have to do is change your decimal places from answer to answer. It's the same numbers, right? So if you multiply it once, that'll give you the answer. Then use what we've just taught you to figure out what the answer will look like. Okay? This should take you guys about 3 minutes. Go. You may work together as a table. Guys, so this is one of those you either get or you don't. My 2 numbers, 26 and 31. So I multiply them. I'm going to get 26, 18, 6, 7, 6, 0, 8. So those are the only 3 numbers I'm working with, right? So every single time, it's going to be 806. Now I have 1 decimal place, so I put in 1 decimal. 806. I have 1 there is 2 decimal places. Put in 2 decimal places. Here I have 2, I've got 1, gives me 3 decimal places. So 806 with 3 decimal places. Here I have 3 decimal places. So 806 with 3 decimal places. Here I've only got 2 decimal places. So that gives me 806. Here I've got 1, 2, 3, 4 decimal places. So I still have the 806, but I need a 4th decimal. So I need to add a 0 in front of it. Now I'm up to 5 of them. So I still have 806, but now I need to add 2 zeros. Here I'm back to 4 decimal places. So 806, I need a 4th decimal place. I add another 0. Is that starting to make more sense to everybody? Good. Now if you can just do your homework. Okay, let's turn the page. Selena says, write a 0 at the end of a number to multiply by 10 and 2 zeros to multiply by 100. So 3 and 2 tenths is 3 and 20 hundredths. 3 and 2 tenths times 100 is 3 and 200 thousandths. Is she right or wrong?
Wrong.
Why? That's actually a good reason, Tina. The thumb's pointing down. So they told us she's wrong. The key is why. What did she do incorrectly?
So what you're supposed to do is move the decimal point, however many zeros there are. But what she did, she just literally put 2 zeros at the end.
Good. So it's really move the decimal, not just add zeros. So she was correct in the case of whole numbers. If it's whole numbers, I'm multiplying by tens or hundreds. All I'm doing is adding zeros. But when I throw the decimals in there, it's actually just moving the decimal. Okay? Explain to Selena similarities and differences between those. I'm actually not going to stress about that because we're down to almost no time. Here's another one that we got wrong. This one I actually want you guys to take 2 minutes. Talk about. See if you guys come up with what she did wrong. Okay, guys, who was able to figure it out? What's that, Jet? What about the calculator? But didn't we just go through a whole piece? If I have 4 decimals, I need 4 in my answer. Does that give you 4 decimal places? So It does?
Wait, no. Wait, why is there 2 decimals now?
That's a period.
Oh.
So what happened, guys?
They did it wrong. No,
Who did it wrong? The calculator?
no. Wait, Camilla did it wrong.
How did Camilla do it wrong?
Because there was supposed to be a 0 there. They just got rid of it because it was one needed. It was a 0 and 15.430.
There's actually a 0 there when I calculate it. The calculator, though, will automatically drop that last 0. So the calculator was correct. It just had a trailing 0 that had no value, so it dropped it. Okay, let's turn to our homework. Page 145. No, 143. Oh, I couldn't read my own handwriting without my glasses. Okay, guys, don't forget your journal entry. Second quarter, I'm no longer taking homework if you don't have your journal entry. Okay? Practice. Insert decimals. Now, one thing I like about this one, sometimes the answer doesn't have decimals. Sometimes the product doesn't have decimals. So, there's going to be a lot of correct answers for B. You have a lot of options. Make sure you put them in the correct spot. Number 2, estimate and then calculate. I need 2 answers for every one of those. Make sure you've done both the estimation and the calculation. Backside, determine the volume. Remember, volume is length, width, height. Guys, you really need to listen on this one. They've given you complex figures to find the volume of. So, this one, find the volume of the big box, find the volume of the little hole that's going all the way through the middle, take it out. On this one, you have 2 options. You can find the big box and then take away this little box, or you can break this big box either this way or this way and figure it out. Actually, I take it, oh, you can do, because they gave you both those measurements, okay? Oh, God.